Module 5, Lesson 8. Today's lesson is another wedding, another marriage. You already know how to do area of figures. You know how to do distance on a coordinate plane. You know how to read coordinate planes. So today we're going to find the area of polygons on the coordinate plane. Okay? So before we jump into the notes, I just want to review a few things. So take a look at the board and the different figures on the board. The first figure, square. How would we find the area of a square? Yep, we could do area equals base times height. What else could we do for a square? Yep. Anybody have something else? Please stop playing with the pencils and just listen. Let's just have a quiet conversation. What else? Side times side, which is side squared because it's a square. Okay? We could do side times side because I told you it was a square. What about the second figure, a rectangle? How would we find the area of a rectangle? Yep. We're most familiar with length times width, but we could also use, yep. Now the next shape is a polygon. So if on the last quiz you took, if you wrote polygon, I did give you credit. However, when you are identifying a figure, you always want to give the most specific answer. So yes, that is a polygon. What else could we call that? We could also call it a quadrilateral, but the most specific answer is parallelogram. All right, how do we find the area of a parallelogram? Well, we can't do length times width because that width doesn't help us. So what do we have to do? Base times height. We cannot use length times width. We have to go with base times height for a parallelogram. Oh, look at that lovely triangle. How would we find the area of that green triangle? Yep. And we could find the height interior because it intersects the base at a right angle. For this one, we would be able to find our height either interior or we could find our height exteriorly. I don't know if that's a word. I just made up another one. Yeah. All right, what about this one down here? How would I find the area of this yellow triangle? Yep, again, all triangles are half base times height, and I could find my height here. Now, we need to have a little chat about this next figure. Yes, it's a polygon. Yes, it's a quadrilateral. Give me the most specific name for it. It's a trapezoid. Is it a parallelogram? No. Parallelogram has two sets of parallel sides. This only has one. A lot of you on the quiz tried to do base times height for that figure. But here's the problem. That won't work. If that's 14, and that's 9, well, which is your base? You can't. But what we did know was the height. So a lot of you were like, okay, I have to, use composition to calculate this. So some of you saw this and said, all right, I'll find the area of the rectangle. That's half base times height. And then that leaves me with this. So then some of you brought that down and did base times height. What's the problem with that? That figure on the left, what figure is that? What figure is that? Trapezoid. Another trapezoid! A lot of you fell for the trapezoid. So, a lot of you use base times height for this. We cannot do base times height. That's not a parallelogram. What you needed to do was cut that again. So the trapezoid had to be broken into that triangle, that square, and that triangle. But don't get trapped by the trapezoid. There is a formula for area of the trapezoid. It does have its own formula, but that's not something we are going to explore and discover in 6th grade. That's just, believe me, I'd love to teach it to you all, but those 7th and 8th grade teachers get jealous. I got to save something for them to do with you. Now this last one, what figure would you call that? It's a polygon. Let's get more. There is one more specific. It is irregular. Quadrilateral still has 4 sides, but it's an irregular quadrilateral because the sides and angles aren't the same measurements. So this one we would have to break apart. It looks like I can find a triangle here. It looks like I'd have to find a triangle here. Find a triangle here. And then that leaves me with a nice rectangle in the middle. So you might have to get creative like we did with the hockey stick last week to find shapes that you know the formulas for. Don't just assume that all 4-sided figures are base times height. So that's what we're going to continue to do today. We're going to review this concept, but we're just going to put the pictures on a coordinate grid. We can do that. So now the note sheet in the module I felt didn't give you enough room to work. So the notes that you took from the outbox are the same as in the module. I just made them a little more user-friendly. Okay? So take a look at number 1 on your note sheet. You should have this on top of page 35 in your module. This is lesson 8. It goes on top of page 35 in your module packet. So number 1, plot and connect points A, B, and C. I already did it for you. So to save time, I already plotted the points for you. Name the shape and determine the area of the polygon. So what shape is that? It's a triangle. If we want to get more specific, we could say that it's a right triangle. Now, we reviewed distance on the coordinate plane yesterday, so using our knowledge of distance on the coordinate plane, what is the distance from A to B? I'm going from 2 to 7. So from 3, 2 to 3, 7, what's the distance? They're both positive numbers, so I didn't cross an axis. 5. So my height is 5. And now from A to C, I'm going from 3, 2 to 8, 2. So what is my distance from 3 to 8? 5 again. So now that I have the, can I find the measurement of BC? That's one of the things we're going to let the 7th and 8th grade teachers teach you. There is a way to find the measurement of a diagonal line. It's called slope, but we're not going to do that in the 6th grade. We'll save something for them. So but do we need the measurement of BC? No. No, I've got my base, I've got my height. So we're good. First step, write the formula. Second step, replace the variables with their numbers. Step 2, start multiplying. And then label my answer. Sometimes in the directions, they will tell you, like if the coordinate plane is representing something in the real world, like we did the ones with the map, like going to the dog store, the leash collar thing. So sometimes the directions will tell you that each box represents 1 mile, or each box represents 1 foot. So sometimes they'll give you the unit, but in this case they did not, so we'll just call it units. So are there any questions on where those numbers came from, or why I multiplied, or why I labeled it, or how I found the distance? Where did the 5 come from? Where did the 12 come from? So far, so good?
Yeah.
All right. Let's try the next one. Smarty Pantsuses. All right. Oh, woo! Not a triangle. All right. We like triangles. All right, so 3, 2. We need to find the base and the height. So take a look. What's my base? What's my height?
I don't like this.
Uh-oh.
I know what it is.
Oh, no. They're all diagonal lines. There are no horizontal. There are no vertical. And so far, every class has told me the way to solve it is to skip it, and that's not okay. We don't back away from challenges. We can do this. Just because they're a diagonal line doesn't mean we can't solve it. It means we need to get a little creative and think way back to last week. And how's another way that we could solve this? So I can't draw my height here because then that would not intersect at right angles. So the height there wouldn't work. So I can't even try to break this into smaller triangles because then I still have diagonal lines. So instead of breaking that into smaller, how can I get some vertical and horizontal lines on there? So maybe if I found the height of my figure here, that represents the height of the figure. So why don't we go ahead and box it out? But now, that's too much area. I don't need the area of that whole square. I just need the part of the triangle. So since now my square is too much, I have extra space here. What am I going to do with this extra space? Because I only want the area of that. So what do I have to do next? So what I'll do is I'll find the area of my red triangles and then take them away, because what's left will be the blue area. So with your colored pencils, why don't we color in the sections? So I boxed it out, so now I have section A that I chose to make yellow. Section B I made pink. Section C I made green. So if I find the area of my red square, and then I take away those extra external pieces, that'll leave me with a piece in the middle. So right now we have to find the measurements of our sides. So for our red square, what is the base and the height? Well, I went here from -2 to -8. So what's the measurement of that side? 6. And my height goes from 2 to 8. So what is my height? 6. So the square is base times height. 6 times 6, 36 units squared. Okay? Any questions on how I found the area of the square? So now let's find the area of triangle A. What's the formula for a triangle? 1/2 base times height. So what is the base here of triangle A? What is the base of A? It's just going from -7 to -8. So the base is 1. What's my height of A? 6. So the yellow triangle A is 3 units squared. Questions on where the 3 came from, the 6, the 1. Half of 6. I used the commutative property for multiplying. I took half of 6. Here, the base is just 1 unit of just the yellow A. We're looking at just the yellow triangle A. Now let's do B. What is the base of B? 6. And what is my height? It goes from 5 to 8. So if my base is 6, what's the height of just the pink triangle? 3. Half of 6 is 3. 3 times 3 is 9 units squared. Questions on where the 3 or the 6 or the other 3 or the 9 came from? Right, I'm giving everybody a second to catch up. Right, let's take a look at triangle C. Triangle, the area is 1/2 base times height. 1/2, what is the base here? Just that part. It doesn't go all the way across. So what is the base of C? 5. And what is the height? 3. So 1/2 times 15. So 7.5 units squared. We're okay with all those, where those all came from? Yeah. Now, we have to find the area of just the triangle. So we found the whole square. We found those extra pieces that are surrounding our for real triangle. Remember, this is what we really want. We really want to find that. So let's take the square and then break away those extra triangles. So my 3 extra triangles are 3 plus 9 plus 7.5. So my extra external triangles are 19.5. So if the square was 36 minus the extras that we created when we boxed it out and made it bigger, remember you cannot just drop down that 5. You have to add that 0 so that you can regroup. So your answer is 16.5 units squared. Now let's take a look at number 3. What kind of a shape is number 3? Number 3 is a polygon. How many sides are there? 4 sides, so it is a quadrilateral. So I kind of already put the answer on there. How to separate that? So if we draw that red line, that creates 2 triangles. Can I find the base and the height of both of those triangles, A and B? So let's see. Oh, it won't let me move it over. All right. Let me see if I could try that again. All right, so now if we look at just that, can I find the height? If I go from here and drop down, this isn't working. All right, I tried to be creative. So I could go from here and drop down and find my height of triangle A because it forms a right angle with the base. So for shape A, I can find my base times my height. What is the base of shape A? The base goes all the way across. So what is the base of shape A?
6.
And what is my height? What is my height?
4.
So shape A is 12 units squared. Now shape B. I cannot draw an internal height for shape B, so I'm going to come out here and do an external height for shape B. So we have 1/2 base times height. What is my base of B? What is the measurement of just the base of shape B?
Last year I had a question. Wouldn't the base of triangle A be 5?
We're going from 1, 2, 3. So from -3 to -9 is 6 units.
Oh wait, I was looking at the shape of shape
You
C.
can't.
Oh, that's the height.
So now for B, what's the base?
2.
2. And what's the height?
3.
Half of 2 is 1. So now I have to add my A and my B together. So 15 units squared. Okay? Now I decided that instead of doing the problem sets for lesson 8, you can do number 4 in the note packet because it's all laid out and plotted and the room to do the work. So before I send you home with number 4, I do want to talk about it for a minute. So look at number 4 in your note sheet, and let's look at how it's organized. First, they asked us to identify the best name. So what's the best name for that? It's a polygon. We don't, it's a pentagon is the best name. Now, we're not for sure if it's regular or irregular because we don't know the measurements of the sides. It looks like a regular pentagon if we had to guess, but we're not sure because we don't know the measurements of the sides. So now we can't go right ahead and do base times height. So there are 2 different ways that you can solve this one. One way you can solve it is to break it into triangles and squares internally, or you can choose to box it out and then take away A, take away B, take away C, and take away D like we did for number 2. Or you can choose to look at the interior shapes and then add them together. This is set up for solving it this way using composition. If you choose to solve it using decomposition, you have to add one more area, the area of the whole thing, and then subtract A, B, C, and D. So it's up to you which way that you want to solve this. Just make sure you show all your work on your homework.